All right, so I ended the last video talking about integration by parts and saying that I was going to give you an example of repeater. My battery on my pen was also dying, so now I've replaced that. So hopefully we're in better shape. I just want to look at a couple of these and say, which would you pick as u and which would you pick as v? Well, I would pick x for u, and I would pick e to the negative x for v. I would pick x squared for u, and I would pick cosine of 3x for v. Okay, I would pick, in this case, x squared for u. So, and in 7, I would pick x squared for u. In 9 is one of those examples where I might insert a 1 and make a 1 look like the dv. 10 is an example of a repeater. So if you think of number 10, both cosine of 2x and e to the negative x, they're never going to dwindle down to 0. So you might be like, well, how could I ever do that? Well, I'm going to show you. There's a way. So let's say I have an example like integral of e to the x cosine of x dx. And let's say I make u equal to x, and I make dv equal to cosine of x dx. Well, v is going to equal to sine of x, du is going to equal to, this is e to the x, so du is going to equal to e to the x dx. So now I have uv, which is e to the x sine of x minus the integral of v du, which is sine of x times e to the x. Okay, we're not that much closer yet. However, I may have said I don't do integration by parts a second time in the last video, but that was just the thespian in me. I don't know. I was doing that for drama. I can do it a second time. That's all I'm trying to say. So I'm going to make sine of x equal to dv. And now I'm going to make du equal to e to the x again. And I'm going to make dv, and v is going to be negative cosine of x. So if I write this again, I get integral of e to the x cosine of x dx equals e to the x sine of x minus the whole thing, which is uv, which is negative e to the x cosine of x minus the integral of v du, which is negative e to the x cosine of x dx. Now, these things do get kind of confusing with parentheses, but let's say I've got I'm going to turn those things both into plus, and then I'm going to turn this into a plus, which turns this into a plus and this into a minus. So I get integral of e to the x cosine of x dx is equal to e to the x sine of x plus e to the x cosine of x minus the integral of e to the x cosine of x dx. Now notice what I have here, because this is kind of convenient. What am I trying to solve for? I'm trying to solve for this whole expression. What's the part that's tripping me up that I can't seem to get through? It's this expression right here. Okay, what's the problem? It's that I've got an integration expression on both sides. However, since they're the same, what would happen if I added this whole expression, integral of e to the x cosine of x dx, to both sides? These would cancel, and I would be left with 2 integral of e to the x cosine of x dx is equal to e to the x times sine x plus cosine of x. Well, then I could just divide by 2. And that would be your answer. And there would be a lot of other ways that you could express your answer without using the parentheses. That would be fine. The only reason I did that was just to show you that it could be done. Hopefully that helps and that makes sense. The ones that you'll have to do will probably get a little bit trickier, but you shouldn't have to do them more than 2 times. And mostly when you do a repeater, when we have them, it'll be the same thing. The reason it repeats the second time is because sine and cosine go through this 4-part process where they're like the opposite of their self halfway through it. And that'll be the part that you need to get to.